Okay, good morning. In this video, we are going to go through the MCQ questions of the Prelim 1, Paper 1. I have selected those questions whereby more than 50% of you got it wrong. So, if you still have other questions that you are not sure why you get it wrong or why is that the correct answer, please do not hesitate to come and look for me. You need to find out and learn why is that a wrong answer so that you can benefit from this prelim examination. So let's begin. Okay, in question 2, okay, so in this video, if you see a red highlight on the MCQ option, it means that this is the option whereby about 50% of you have selected. The yellow highlight here actually represents the correct answer as shown in the answer key. Okay, now in question 4, you are asked to identify which part of the journey shows a uniform acceleration. Be very careful because down here, you are looking at a displacement time graph. And in a displacement time graph, you can only obtain one useful information from the graph, and that is the gradient is equals to the speed. So having this content knowledge, it will assist you in answering this question. So now I'm going to break the graph into 4 portions. So let's look at OP first. If you look at OP, you will see that you have a positive gradient. And because of that, it means that obviously this gradient is constant. So therefore, you can see that you have a constant speed down here. And if you have a constant speed, that means that your acceleration will be 0. Now similarly in your RS, you will see that you have a negative constant gradient. And because of that, you know that you have a constant speed as well. And therefore you have a 0 acceleration. Now if you look at QR, you can see that the displacement doesn't change over time, meaning that your speed down here would be 0, is stationary. And because this speed equals to 0 does not change with time from Q to R, it also means that your acceleration is 0. Now just to be precise and to reduce confusion, I'm going to erase this and write it down in more specific terms. So down here it should be positive constant gradient. Okay, constant gradient. Now, if you look at OP, QR, and RS, you can see that all 3 parts give you acceleration is 0. And by the definition of uniform acceleration, uniform means that it doesn't change with time. So some of you will argue that, okay, A equals to 0, and this A equals to 0 does not change with time between Q and R. It also doesn't change with time from R and S. A remains at 0 throughout the time. So shouldn't they be considered as uniform as well? Now my answer to you is technically you are right. Okay, A equals to 0, and if this 0 value does not change with time, it can be considered as uniform. But remember, this is MCQ question, meaning that we have to select the best possible option. So if you, in your mind, if you argue that A equals to 0 should be considered as uniform acceleration, then my question to you is, if that is true, then you would have 3 answers, OP, QR, and RS. All 3 of them would have uniform acceleration if you accept A equals to 0, non-changing with time, as uniform acceleration. And you know that it couldn't happen because this is MCQ. There can only be one correct answer. So because of that, using the method of elimination, you can actually already strike out OP, QR, OP strike out, QR strike out, and RS strike out. So you only remain PQ. So in using this method, you only need to analyze, could PQ be a possible solution? And from a displacement time graph, it is difficult to visually confirm that your gradient is actually changing at a constant rate. But like I said, since you have already eliminated A, C, and D, B is your only remaining choice. And using this mentality, B would be the answer. Of course, I am aware that my argument is weak as well. But like I said, this is an MCQ. You have your own limitation. So like I said, using the method of elimination, you can strike out A, C, and D. So B is the only choice. Okay, I know it is a weak argument. Okay, next, moving on to your question 7. You are asked to identify the correct graph, and it seems that you guys are quite weak in this area. So let me give you the general approach to this kind of question. Now, whenever you see a graph and all that, basically they're asking you which gradient is correct. Okay, and gradient is defined by, your gradient is actually defined by the change in your y-axis over the change in your x-axis. So meaning that in mathematic way, you can take it as gradient is actually equals to your y-axis label over your x-axis label. So in this case, you were told that this mass of body is actually being acted upon by a constant net force. And you know that your net force is equals to m times a. And now they are telling you that this F net is given by a constant value. Let's call this value k. So if you know that this value is constant, that means we can play around with these equations. So if you look at your gradient of this kind of graph, and you know that your gradient is equals to y-axis over x-axis, let's substitute them into this general concept equation. So I'm going to use a different color. So now y-axis is your a, x-axis is your 1 over m. Rearranging this formula will give you a times m. Okay, and it is equals to your gradient. So now you have two expressions. This, you have two expressions, this and this. Okay, and you can see that, look here, if my m times a is equals to my gradient, and I know that from the information given by the question, m times a will also give me a constant value. Combining these two information together, I can come up with the conclusion that my gradient is actually equals to a constant. Okay, so this information plus this information give me this deduction. So once I have this deduction, I can see that, A cannot be the answer because the gradient is changing. Similarly, B is also not the case. Then I only have two more options to consider, A and D. Is it a positive or is it a negative gradient? And I can see from here the F net, it is a positive constant. So therefore, my D will not be the answer as well. So therefore, C is the correct answer. Okay, next, question 9. I'm quite surprised that still, how many of you got it wrong? Let's see. 29 of you got it wrong, and actually we went through this in class. So I am a bit shocked. So I'm going to do it one more time. I think the values are almost the same. 5 kg, 2 kg, frictional force between this. So they give you one additional info. There's friction down here. Okay, and the friction is 8 Newton. And I'm asked to determine the acceleration of this 5 kg mass. And I know that this acceleration must be equals to the acceleration of my 2 kg block as well. So I think it is pretty simple. So what I will do is that you need to, okay, sorry. Before you go on to what do you need to do, you also need to have the basic understanding that the tensional force from the rod acting on the block, we'll call it T. This tension must be the same tension that is acting on the 2 kilogram block. Okay, now if you do not understand why the tension is the same, I suggest you go and watch my video on the forces on your force worksheet. Okay, so once you have that, let's isolate the 5 kg body and the 2 kg body. So now I will isolate the 5 kg first. So once I isolate the you can also isolate the 2 kg first, it doesn't matter. Okay, it's just that it looks like 5 kg is easier. Okay, so now on the 5 kg block, I have 8 Newton working here, and I have a tension down here, and of course I would have the weight, which is 50 Newton, but I'm sure the weight will be balanced off by the normal contact force from the table. So this 50 Newton, actually I'm just drawing it for the sake of completeness. Okay, it won't matter, they will balance off each other, meaning that my F net equation, like I said, the step is always the same. I will always write down the two expression for F net. Okay, and I will call this equation 1, I will call this equation 2. Okay, so let's expand on equation 1. Equation 1 is pretty straightforward. The sum of forces is just T minus 8. Okay, I will take the right side as positive. And my F net down here, it will be my 5 kg multiplied by A. I do not know what is my A. Okay, then I do the same thing for my 2 kg block. Okay, why do I move on to the 2 kg block? Because as you can see here, I have an unknown here T, I have an unknown here A. I only have 2 equations. So I do not have enough information to help me solve this problem. Okay, so let's move on to the 2 kg. 2 kg, the forces acting on it will be the weight itself, which is 20 Newton. And of course, I would have my tensional force T here. And I do not know, there's no left or right forces acting on the 2 kg block. So again, same thing. Okay, I will write down the two expression for my F net. First is the sum of forces. Second is the F net equals to MA. So I have these two expressions. So now I will expand on my expression. F net is equals to, I will take this as 20 minus T. I will take downwards as the positive. Down here I would have F net equals to 2 kg times acceleration. Okay, so what do I do now? I have so many different unknowns. Okay, now look here. This F net and this F net refers to my 5 kg block, right? Meaning that the F net must be the same. So this means that I can combine the equation. So let's combine them. So this equation here and this equation here can be combined. So I would have T minus 8 is equals to 5A. This one is from my 5 kg block. And I will do the same thing. This F net, my color, this F net and this F net is referring to the 2 kg block, meaning that they are the same. Now please take note, this yellow F net and this green F net, they cannot be equate to each other. The reason why is this yellow F net refers to the 5 kg block. So I better color this. Okay. So, like I said, I'm going to combine this equation and this equation together. So from the 2 kg block, I would have the formula 20 minus T equals to 2A. Now I have two unknown, two equation, and what I want to find out is the acceleration. So obviously this turned into a simple mathematical question. Let's choose a color. Okay, so let's make T the subject here is very simple. And of course, I'm going to substitute it into this equation. So I'm going to substitute this in this. So I would have 20 minus bracket 5a plus 8 equals to 2a. Then I just need to expand this. Okay, I would have 7a. 20 minus 8 will be 12. And therefore my a is 12 divided by 7. So let's check, what do I get? Yep, I will get 1.7. Okay, so that's how I do it. Okay, in your question 21, it is just specific heat capacity, and judging from your paper 2's working, it seems to suggest that you forget that your thermal equilibrium temperature is an unknown. Okay, you cannot assume to take the average. Okay, so for this, let's write down the energy transfer equation, and please do not be stubborn and try to follow my way of presentation. Okay, because by expanding it like left to right hand side equation, it makes things way clearer to the marker. Okay, so if you do not know what I'm referring to, please pay close attention. So 200 grams of ice is put into water. So definitely, sometimes when you just write this expression that the energy lost by water is equals to the energy gained by ice, sometimes this expression itself would be 1 mark in your structure, in your paper 2. So it is always a good practice to always write down the energy conversion expression on top. So energy gained by ice is pretty simple. First, there will be the energy gain. In this case, the ice started off at 0 degree, meaning that it will just melt. Okay, so there will be energy given off during melting plus the energy used to increase in your temperature. Okay, in the case of water, the energy lost by water will be just the energy lost through the decrease in your temperature. So once you have this, it is quite clear. You can do it component by component. So by presenting it this way, you will ensure that you do not miss any of the steps. So the first step is the state change, the energy gain to melt the ice, and it is given by mass times the latent heat of fusion. Then after that, you will get the mass of ice multiplied by the heat capacity of water multiplied by the change in temperature. So the change in temperature is your equilibrium temperature, which is your final temperature, minus 0. So I do not know what is this final temperature is, therefore I must give it a algebra. Then after that, on the left hand side is just the mass of the water multiplied by the heat capacity, and the change in temperature is, at the very beginning, this water is at 50 degrees C, is going to decrease to an unknown temperature T, which I do not know, so I have to give it an algebra. So with that, put in the mass in kg. So this is 0.2. Latent heat of fusion is 3.36 times 10 to the power of 5. Be very careful, check the unit. This is in joules, not kilojoules, so I can directly plug in. It's in per kilogram, so I change my mass to kilogram. Plus, my mass of the ice is still 0.2 multiplied by the heat capacity of water because it has already melted. So I can use 4200, and then T minus 0 will give me T. Do the same thing, mass of water is 1. Heat capacity is 4200. 50 minus T. Later I would have to expand this equation. So go and do your mathematics, do. You should be able to get 28.3 degrees C. If I make any mistake, do let me know so that I can update this video. Okay? Okay, question 24 is a bit tricky. Just to make sure that I don't confuse you, I'm going to change this. I forget to animate this. It is very hard for one to let me see what is each of them. I think this goes here. Okay, hopefully it comes out correctly. Okay, your question 24. So most of you choose C. I think you all don't have time to really analyze it, but if you analyze it carefully, just use a bit of geometry, you should be able to get the answer. So let me go through with you. So the mirror is rotated. Before the mirror is rotated, you should get the reflected ray. Why is it important to get the reflected ray? Because the question is asking you the refracted ray will turn by how much. So you need to first establish this line and use it as reference, because after the mirror is rotated, you will get a new reflected ray, and you need to compare this new reflected ray with the old reflected ray, which is the reference, this gray color line that I highlighted. So now the mirror has turned. So this blue line represents the new mirror position. This dotted line is the new normal. So with that, you were told that the mirror was turned anti-clockwise by 5 degrees. So that's how I get this 5 degree out. Okay. Now, once it turned 5 degrees, then you should see that now the incident ray makes an angle of 35 degrees with the normal, meaning that the new reflected ray will be 35 degrees from this normal line. Okay. So I will just highlight it so that you can see. Can you see from this to this is, from this to this is 35. Okay. This to this is 35, including this thing. So this is 35. So now you have this new reflected ray. You want to find the angle between the gray, the old reflected ray, with this new reflected ray. So how do you do this? You have to use a bit of geometry and imagination. Can you see this part here? So this red color angle is the old reflected ray with the old normal, which is here. So if you blown it up, you would have the old normal with the old reflected ray. This itself is 40 degrees, and then you have your new normal and your new reflected ray. Okay, this between the new normal to the new reflected ray, this is 35 degrees, and you are supposed to figure out how much is this angle. So this is 40, and so how do you do it is that you know that between the old normal to the new normal, this part here is 5, so therefore this part here will be 30, correct? And you know that this is 40, the red one, this is 30, so therefore this thing down here will be 40 minus 30, which is 10 degree, and it rotates anti-clockwise. So that's how you get your this thing here. Okay, yeah, so just do this question carefully and you should be able to find out why. Okay, your question 25, actually there are multiple ways of doing this. The first way is by studying your EM spectrum. If you study your EM spectrum, you will know that your red color light would have slightly higher wavelength and lower frequency when you compare it with the violet. Okay, with the violet visible light. So since you know that this white color light is produced by a source, it would have a certain frequency. And when your wave enter into a different medium, this frequency will not change. The frequency will be constant. So if the frequency is constant, and you know that your red color has a higher wavelength compared to your violet light, then you should be able to make the deduction that by your V equals to F lambda. Now your F is constant, so your red color light, which have a higher wavelength, would definitely have a higher V, because now your F is constant. So similarly, using the same logic, you would know that your violet light will have a smaller V inside the prism. Okay, now some of you will argue with me, and teacher, isn't it that all the wave in EM spectrum have the same speed? You are correct, same speed in vacuum. Okay, this is when the light is inside the prism. When the light is inside the prism, they will be slowed down by different degree, okay, by a different amount. So therefore your red and violet light will bend differently because the speed is now different inside the prism. So if you have this understanding, then it is quite clear that your option D is correct, because red light has a greater speed and that there is no change in frequency. Okay, the only change is your wavelength. The only difference, no, sorry, not change. The only difference is your wavelength. Now, another way of doing this question is that you study the diagram carefully. So let me get rid of all this thing. Wait, I will just pull this down so that it doesn't block the front. Okay, now look at this. I have drawn a normal for you. This is the normal. And you can see that if you allow the white light to carry on its original path, you can see that the red light bends by this much. This is the bending of red color light. And the bending of the violet light is much more pronounced. Meaning that when the white light enters into the prism, the red spectrum actually has lesser bending from the original path. And the violet light has much more bending, so meaning that the amount of bending that it experiences represent the amount of change in speed that the light is experiencing. Okay, just imagine if this is the light beam, going into the prism. Oh, I have to change it to this side. Okay, if this is the light beam, no, how should I position it? It's mirror image. Wait. Okay, if this is the light beam going into the prism, if this is the this is the wavefront going into the prism. Okay, if it is in air, it will go straight, no change in speed. But now when your wavefront go forward, hits the prism, this part will hit the prism first, right? So if this part, which is in the prism first, experience a slowdown of speed, then your wavefront will start to turn. Agree? And how much it turns depends on the difference in speed between this portion and this portion. So if this guy is really slow, let's say this guy, the speed is 0, this guy, the wavefront on this part, it is going at full speed, it will turn almost 90 degree. Right? It will turn almost 90 degree. So if it gets slowed down like really bad, the bending will be much more pronounced compared to a wavefront whereby the speed down here is not that affected. So it will go this way and go like that. Okay? So you can actually do this question conceptually, or you want to do it using maths alone. Both is okay.